Okay. Hi everyone. My name is Cate Stone, and this summer I had the opportunity to learn about wastewater and seafood processing as the OASE wastewater pollutant and BMP intern with Pacific Seafood. And today I'm super excited to share a little bit about my project. So just a very brief about me is that I grew up here in Portland and I'm a rising senior at UC San Diego, majoring in environmental systems. And I'm really interested in pursuing a career related to water resources and pollution prevention. And I was super excited to learn about this project. In this presentation, I'm going to share a brief overview of my host business, Pacific Seafood, what my project was about, and then highlight one of my BMP recommendations and a couple lessons that I learned. And just to clarify, BMP is an abbreviation for Best Management Practice. So Pacific Seafood is a family-owned and operated company that's dedicated to providing the healthiest protein on the planet, which is seafood. They were created in 1941 here in Portland, and today they have over 3,000 employees in 40 locations, and they process over 40 seafood species. They manage all parts of the supply chain from processing and aquaculture to distribution in order to provide customers with fresh, sustainable, and high-quality seafood. The overall goal of my project is to find ways to reduce wastewater pollutants from entering the surface water by improving or implementing new best management practices. This is motivated primarily by Pacific Seafood's internal drive to sustainably optimize its supply chain, for example, ocean health, in addition to stakeholder engagement, for example, nearby communities, and as well as more stringent government regulation and oversight. For example, meeting revised limits set in the new permits from the Oregon DEQ. This is a very general overview of my 10-week project. First, I gathered background information and learned a lot about Pacific Seafood's facilities, the seafood industry generally, and how processing works, as well as how wastewater is generated and treated. Next, after conducting a literature search and visiting a couple of sites, I identified an area of focus, which is solid separation, as well as a couple BMP recommendations. And finally, we did a pilot study. Two of the photos are here. And I began summarizing the findings of the project into a written report and presentations. As I learned, reducing wastewater pollutants from the seafood processing industry is a broad and multifaceted challenge. Each species processed and each step within each processing line, from offloading to packaging, affects the end-of-line wastewater pollutant concentrations differently. For this project, due to the very limited time, I chose to focus on the 3 processing facilities in Oregon, Warrenton, Newport, and Charleston, and 2 types of seafood. And just for reference, this is what whiting and shrimp from the Oregon coast look like. And also, there are over 10 wastewater parameters. And so for this project, I just focused on 3 of them, which are biochemical oxygen demand, or BOD, total suspended solids, or TSS, and oil and grease, or O&G. Another part of my project scope is focusing on pollution prevention best management practices, which is the focus of the OASE program. In seafood processing, wastewater pollution prevention and treating wastewater upstream can have a really large impact at a low cost. And in wastewater, an example of the top of this pyramid is solid separation, while disposal can be an example of end-of-line treatment and discharge. And the big idea driving all of my pollution prevention best management practice recommendations is the importance of reducing contact time and increasing solid separation as much as possible and as early as possible. So what does this mean? Well, as contact time between seafood scraps and wastewater increases, for example, in the processing area, in the pipes, or in treatment systems, fish solids break down and dissolve more, which is something that's unique to seafood. The result is that wastewater is harder and more expensive to treat downstream. This is backed by numerous studies, which have demonstrated that in comparison to end-of-line treatment, point-of-generation treatment, so upstream, can reduce construction and maintenance costs by over 75% and reduce end-of-line BOD, TSS, and oil and grease concentrations by 40% or more in comparison. My project focused on three main categories of BMP recommendations, but I just want to highlight one, which is conveyor belts that separate shrimp shells from wastewater as early as possible under the peelers. This minimizes contact time between shrimp shells and wastewater, which currently aren't separated until the last stage of treatment. Pictured here is a peeler that's similar to ones that are at Pacific Seafood for reference, and a simplified floor plan from our Charleston facility that shows two places where conveyors could go. And both have their own engineering challenges for implementation, like space and managing water flow, but it definitely could be possible to design and implement this BMP with sufficient time and planning. And in order to see how the implementation of this BMP could potentially impact wastewater pollutants, we conducted a pilot study at the Charleston facility. Using flow from one peeler, we collected water samples in the floor drain a little after removing the shrimp shells and found promising results. And this is a table that summarizes the three main categories of BMP recommendations in my report. Point of generation treatment for shrimp shell removal, like the conveyor belts, as well as improved wastewater conveyance and equipment improvements. And just to compare these numbers to things we might be more familiar with, if all the BMPs recommended in the report across three facilities were implemented, the annual total amount of BOD that could potentially be reduced is the equivalent to taking 46 days to be decomposed by bacteria. The pounds of oil and grease across the three facilities that could be reduced is equivalent to over 900 gallons of oil. The pounds of total suspended solids that could potentially be reduced is equivalent to the weight of 18 Toyota Priuses. And I learned so much during this project, but I just want to highlight a couple of lessons that I learned and takeaways. And one takeaway is the importance of reducing contact time and increasing solid separation as much as possible and as early as possible because of its cost effectiveness and its impact on end-of-line wastewater pollutants. Another is that the implementation of BMPs and wastewater treatment needs to be specialized to each facility and processing line because each is so different. And a third is that a lot, or really almost all of the literature that I found about reducing contact time and also just about wastewater pollution prevention practices in the seafood industry was from 2003 or earlier, but really mostly like the 1970s and 1980s. And I think that this highlights a gap in knowledge and the need for more current research. And with that, I just want to say a big thank you to Ben Mitchell, who is my internship supervisor, as well as all my colleagues, a bunch of whom are here in person today, as well as my OASE project team, including Lisa and a couple others, and many more who helped support me and mentor me throughout this project. And any questions?
Okay, are there any questions online or in Washington? I think this was a really challenging project because there were so many components. It was a more regulatory focused project, which was, a little bit different for us. So there was lots of moving parts. So I'm really impressed with how well you got through all of those different scenarios. So good job. Okay.